picture on the right-hand side, you can see that there's many fixtures in the area. Now, I would venture a guess that not all of these fixtures would be emergency fixtures. Some of these fixtures would be normal fixtures, and then some of them might be emergency fixtures. A couple things about battery packs and emergency fixtures. So one thing you need to note is that in this picture, if maybe a quarter of these fixtures were battery pack fixtures, that would mean that you would physically need to be swapping out battery packs in these fixtures. You would also need to do the monthly and annual testing of these fixtures by going up to each individual fixture. How inverters work, they take those battery packs out of the fixtures and they centralize all of that battery power in one area contained within the inverter itself. I'm going to get more into centralization of inverter function in a minute, but the main idea here is that when a power is lost, so these batteries are charging during normal power operation, the output, the utility power is being passed directly to those commercial fixtures. Batteries are charging, but when the battery power is lost, when the utility power is lost, these batteries are now going to discharge. The inverter is going to be the power supply for those commercial fixtures in the space. The main takeaway: power loss, fixtures stay lit. So let's jump down to the 1,000-foot view of the different types of outputs or circuits or output circuits on an inverter. Again, utility power on the left-hand side coming into the inverter, and then we have the outputs of the inverter. We can have three different types of outputs: normally off, normally on, and switched outputs. So in normal mode, when there is normal utility power present, our normally off output would be off. So that would be basically any emergency fixture that only needs to come on during a power outage. The normally on output would be always on, whether in emergency or in normal mode. And that would be typically referred to as a night light in our industry, or a light that needs to remain illuminated 24 hours a day. And then you have your switched output type. The switched output type is going to trigger off of a wall switch. That switch command is going to trigger the inverter to turn the switched output on. So we're running the wall switch output directly to the inverter and allowing the inverter to do the switching for us. When there's a power loss, though, something happens. This normally off output will come on, the normally on output would stay on, and then the switched output would also stay on even if the switch is in the off position. In other words, when there's a power loss, then all output types that are on an inverter would be in the on state. So let's talk a little bit about code compliance. And the reason I want to talk about code compliance is because it's directly related to the practice that happened in the past of always specifying battery operated fixtures. The NFPA 101 Life Safety Code, section 7.9, is specifically dealing with emergency lighting systems. So an emergency lighting systems is basically everything that is contained in, that is part of the emergency lighting system. That is the following. So we're talking about the emergency fixtures in the space. We're talking about any wall controls that might be on the wall, or an aux sensor, any type of control that might be triggering those lights to go on and off. Any type of bypass devices that are used to bypass those controls, and then anything that is providing the power to that system. So in this case, in our case, we would be included in that. The inverter would be included in part, as would be considered as part of the emergency lighting system. NFPA code dictates that you must test the emergency lighting system for a period of 30 seconds monthly. You also must test that system once a year for a period of 90 minutes. That would be considered to be a full discharge test. These are things that absolutely need to happen and are mandated by National Fire Code. Testing and failures also must be recorded. So anytime that the system loses power, that also must be recorded. And then anytime that there is some sort of failure with the system, that also must be recorded. So why am I telling you this? In the past, there was a great deal of manpower involved with going around and testing these battery pack fixtures. So you would physically have to walk up to each fixture, press a button on the fixture, and then also you would need to swap those batteries out as well. Now that can be a very costly procedure because it's very, very labor intensive. The reason I bring this up is because if you were to use an inverter in the design, you no longer have that added cost. Basically, your maintenance costs are next to nothing because you're no longer requiring to replace a battery pack in an individual fixture, and you're no longer required to physically go up to each fixture and test it. The inverters are going to run those monthly and annual tests for you automatically. So it is literally zero hit human interaction to be compliant. The reports are stored locally. And then on top of that, we have a service that is connected to our inverters called Lifeguard Web Monitoring, which is available 24 hours a day. And I'd like to show that to you right now.
Evenlite. It's not just a name. It's a trusted solution for national sports stadiums, entertainment destinations, critical national data centers, and the world's largest software and technology firms. This video will introduce you to Lifeguard, the most comprehensive and user-friendly inverter monitoring system in the industry. It's a web-based platform that makes your building fully compliant. It automates your inverter monitoring and testing, so you never have to worry about it again. Oh, and it's free. So let's check it out. We log in from the Evenlite website. And we're in. Here's our inverter, and this is our overview page. We're actually watching our inverter here in real time. We see system status. There's the green light. AC's present, that's good. The yellow light means the charger's running. These lights mean everything is running well. Meter status gives us more detail if we want it. The system is in constant communication, uploading the latest data, so it's just as good as being there with the physical inverter. The National Fire Protection Code requires you to test your inverter for 30 seconds every month and 90 minutes every year. Lifeguard makes it painless. We can test our inverter here with one click. This is an actual test of our inverter done fully remotely. The battery voltage discharges. The test lasts the required 30 seconds. Then, everything returns to normal. All test results are automatically stored right here. But even better, we can set up Lifeguard to auto-test, so we never have to think about it again. Click Manage Settings. We can customize everything. When to test, how often. It can even send us the test report. Everything gets archived automatically. It's all here anytime you need it. And if you really want to geek out, you can get all kinds of test details here. So if the fire chief wants proof you've been following code and testing your inverter every month, just show him this screen or print it out. Lifeguard does it all for you. If there's ever a problem, Lifeguard will contact you immediately. You can customize all alerts, who gets notified and how. You can even set up text notifications. And if there ever is a problem, you don't have to panic and try to figure out what it is. Lifeguard self-diagnoses the issue. You'd see which of these is red and just click it for more detail. This level of inverter diagnosis in a league of its own. The best inverter is the one you can trust. And with Lifeguard, you get the ultimate in peace of mind. It does all the testing, monitoring, and archiving, so you don't have to. And it's free, with every Lightminder modular inverter. And don't worry, at Evenlite, we're always available if you need a hand. We're your partner in light safety because lives depend on us.
All right, so that was the Lifeguard Web Monitoring, and that is free on all of our large LM modular inverters. And speaking of our modular inverters, I wanted to go over briefly the sizing of our inverters and our inverter offerings. We have 4 families of inverters. The EMS family, which is our mini inverter, that is a 32 watt or a 55 watt offering. So this would be a great inverter, mini inverter that would accommodate up to 3 fixtures, I would say, roughly in a space. So instead of having 3 separate battery packs, you could have 1 small inverter. If you want to move up in size, the PW would be great for a single classroom or a single office space, something that is a little bit bigger than just 1 to 3 fixtures. And it's offered in 125 and 250 watts. Now, if you bump up to the LM series, which is a medium-sized inverter offered in 325 and 525 watts, this would be great for multiple zones of lighting. So think a large office space that has multiple zones of lights, or maybe 3 classrooms in a high school. This would be perfect for centralizing all of those fixtures into one area instead of having 15 or 20 battery packs strewn throughout that area. If you move up to the LM modular series, these are true building scale inverters. And what that means is essentially you are taking every single emergency fixture in a building or a floor of a building, and you are allowing all of those fixtures to be powered by one single point, which eases the testing. It centralizes the testing for you. It's automatic fire code compliance. You don't have to mess around with battery packs, swapping out battery packs. And the greatest thing about this is that if you think about how you need to swap out battery packs or test individual fixtures, if you're using battery pack fixtures, quite often that shuts down the workspace. With an inverter, you do not have to do that because this testing is done in one centralized location. There is no maintenance required for swapping out battery packs, and you can literally leave every location up and running and not require occupants to exit the area to do the required fire testing. Now, I did mention that there are 4 lines. We launched a brand new line in the PW line called the PW2. That product is right here for you. So you might have caught that in the video that this is a dimming inverter, and that's exactly what this is. This is an industry-leading dimming inverter. And why I say it's industry-leading is because I'm not going to get into the hard data of this unit. I would urge you to check out the spec sheet on our website. But there are some really incredible features on this unit. There are 3 separate dimming circuits on this. And because the dimming is done by the inverter, you do not need transfer devices. So you don't need those shunt or bypass devices. You don't need UL924 transfer devices. The inverter has all of that built directly into it and will accommodate the transferring of the power and the bypass of the local control, all done within one unit. So you no longer have to specify an inverter and separate transfer devices.
Kyle, I'm going to interrupt you, sorry, for 1 second, just because if people who do not do as much lighting controls, so typically what happens is on the project, when you use an inverter or generator, you have a lighting controls, room controller, or power pack. Then you have an occupancy and daylight harvesting sensor, depends on if you needed daylight harvesting or not. And then you have an override switches, and then you'll have to add a shunt relay for each circuit for the emergency lighting. And that shunt relay acts as a sensing link. So if the Pure Wave new inverter by Evenlite actually has everything already in there, so it first of all, you don't have to purchase all those shunt relays, and second of all, electrician doesn't have to wire them and find the place in the ceiling and stuff like that. So it's a great inverter. And also we had a few questions that have come in, and I think that this would be a great time to
Sure.
to answer them. So first, the EMS and PW, are they inverters? They were ceiling mounted, or where are they located?
Yeah, absolutely. So
Small
if we
little
were to go back just real quick, you were talking about the EMS.
Mhm.
The EMS is a mini inverter, can be mounted anywhere. So you can put it in a plenum space, you can put it on T-bar, you can stuff it in a closet. You can literally put that inverter anywhere. It's very small. The
Is there any
PW,
clearance that's supposed to be around it, or
I'm sorry?
like a clearance? You know, when you put the large inverter in the electrical closet, there is a certain number
No clearance,
has to be from the door and stuff like that. Yeah,
no clearance required.
perfect.
The PW series also it's a little bit larger than the EMS series, but it is still considered a small inverter. No clearance requirements for the PW series. You can put that in a plenum space. We actually sell the T-bar mounts for this as well. It could be hung on a wall. It can be laid flat. It's very versatile. It can literally go anywhere. So again, no requirements for clearance on this unit. It can literally live anywhere.
Sounds good. The next question was regarding the wattage that you have on the bottom of those, under those inverter series. So is it is there a crest factor, or let's say we have 5 fixtures that are 20 watts each? Do we have to put another 15 or 20% to the inverter for to account for the inrush current, or have you guys already accounted in those numbers for that?
Yeah, that's a great question. And I could certainly bring out the spec sheets for you, but as I understood it, this wasn't going to go into a lot of technical detail, but I am going to address that because it is an incredible question. So one, on all of our inverters, you do not have to account for that inrush. And here's why you don't have to. Our ratings on our inverters are a minimum of 4x crest factor. So what does that mean? That means that in a 250 watt inverter, it can withstand a 1000 watt inrush. So really, when we're talking about inrush, I highly doubt that if you had 250 watts connected to it, that the inrush would get anywhere close to 1000 watts. So really, we have accounted for that. We've also accounted for overload. We're talking about 110% overload on these inverters as well for up to 10 minutes. So as far as inrush goes, overload, you're definitely covered. There's a lot of discussion. It's not an easy answer to say, can we specify 250 watts on a 250 watt inverter? It may seem like a simple question, but it's not a simple question. And here's why. So can our inverters on a 250 watt inverter, can it supply 250 watts for the 90-minute period? Absolutely. Matter of fact, our 250 watt inverter would supply 250 watts for more than 90 minutes, but it's rated for 90 minutes. So we really have you covered there. Do I recommend specifying up to 250 watts on a 250 watt inverter? And the answer is no. And I would not recommend doing that on any inverter from any manufacturer. The reason why is there's multiple reasons for this. So one reason is that when we're talking about fixtures, fixture manufacturers generally are looking to build their fixtures as cheap as they possibly can while maintaining quality. Because of that reasoning that happens with fixture manufacturers, they jump from driver to driver. So quite often, if you order a fixture from a manufacturer, it has a driver in it, but then you order the same fixture a year later or even 6 months later, and it has a different driver in it. And that's because there's a lot of competition between driver manufacturers selling to these fixture companies. So when that happens, all drivers are not created equal. So you may have a power factor rating on a fixture that is 1.1, but in all actuality, it might not be 1.1. Maybe the power factor on a fixture is 0.9. Because of that factor of that differential that could happen within fixtures itself, we always advise specifying a little bit of headroom. But there's other reasons to specify headroom as well. I personally, it's very rare to actually have a spec go out, be specified, and then the job gets done, and then the rep gets the as-built back. And if you compare those as-built to the spec, quite often they are not the same. And that's generally because in the workspace, things get changed. Electricians move things around. They take one light and put it on a different circuit. Or you might even have a customer or an architect that comes in and says, I need an extra fixture here or an extra fixture there. So because that happens, I would always recommend specifying a little bit lower than the rating, so that way you have a little bit of headroom in case something changes.
What's the magic number?
So on the EMS and the PW, it's 85%. On the LM, it's 85%, and then on the LM modular, it's 90%.
Gotcha, makes sense. So the larger is the inverter, the smaller is the number. Okay, the last question that we have here: can you speak briefly on the advantages of Evenlite has over the competitors? What are some of the what are some characteristics of specification a designer can reference to distinguish a good inverter versus a bad one? I actually love this question. And the feedback that Lifeguard feature looks awesome.
Yeah, so can I speak briefly about that? I will try.
Yeah,
Olena, it's a very, very complex question. It's an incredible question. And I would, you know, if I came on here and said, no, I can't speak about that, then I'm not doing my job. But if you asked any inverter manufacturer, of course, they're going to tout the features that they have and say that they're the best, and rightly so. But I'm going to say that if you really want to know why our inverters are what they are in the industry, you really need to look at the hard data. Now, I apologize, Olena. I have been away for 2 days. I have been doing training people, field service people to start our inverters up. And I was working real quick. I was working with a company that has been around for 30 years. And they start up all inverter manufacturers. And we finally decided, yeah, we're going to let you start our inverters up too. I spent 2 days with them, and they said they have never seen a design that was more simple with the least amount of failure points. And in the design itself, it lends itself to ease of use, and it lends itself to being highly serviceable in the event that something should happen. So that's one thing that we can tout. But really, if you were to go to our website and look up our inverters, if you just click on our single phase series here, on the right-hand side is a ton of information. But specifically, the question you ask is related to this document right here, detailed specification and technical guide. I could run through this with you, and I could show you all the amazing things that our inverters do, but really when it comes down to it, the down and dirty of it is on page 2 right here. And it comes to some key factors right here. So this really is the crux of the answer. So we are 98% efficient. That is something that other inverter companies cannot claim. We are
is number one when you specify and delight an inverter by, you know, hopefully Evenlite, but if not, then look at the efficiency. What else?
So efficiency, overload capability. These numbers are huge. We are talking up to 400% overload capability for a half a second. So let's go back to that inrush question we had earlier, which was a great question. We can withstand 400% for a half second. So that literally is the inrush you're talking about. So in a 10,000 watt inverter, we can withstand a 40,000 watt inrush. That's a massive, massive number. But the second massive number is this right here. Other competitors cannot claim 120% overload capability for a full 10 minutes. That's a massive, massive number. So those really are the crux of why are we better than at doing what we do than other people. I could talk about our convection cooling. We have convection cooling. Other manufacturers use fans. Because we do convection cooling, there's no moving parts. Therefore, you don't have a failure point. If you were to specify one of the largest names that's out there that we
That starts with an
daily,
M?
what's that?
That starts with an M?
I cannot confirm
Okay.
or deny that, but
Got you.
if you were to specify their inverter, they have fans in there. Well, what happens if those fans fail? Batteries overheat, batteries go into thermal runaway, and you have a potential meltdown on your hands. So, you know, when we're talking about design, we really designed our product to take a beating. And that's what we want. We want to be able to take a beating and keep going. There's lots and lots of things. Modular design. It means that if there is a problem, we can get in there, swap a module out, be out of the inverter in under 5 minutes and have the problem fixed. Our short circuit withstand. We have the highest KAIC rating in the industry. There is no higher rating than 65 KAIC. Again,
Okay.
we were going after massive, massive numbers. So that way we could make the claims that we are better than the competition. And the data supports it. It's not about me saying we're better. It's the data saying that our inverters are better.
Okay, so it sounds like efficiency, crash factor, cooling, type of cooling, really short circuit withstand capability, and price, quality, and delivery. What about the batteries? What so sometimes on the large inverters, actually majority of the times do you ship it ahead as well?
Yeah, so
And
I
then
want
batteries come later?
that's a great question. So let's talk about batteries. So batteries, there really has not been any major advancement in battery design in the last 20 years. But we are using one of the most well-known names that are out there. There's no secret that inverter companies do not manufacture their own batteries. No one does. Every inverter company buys from another company. So we are sourcing Leosh batteries. We believe in those batteries. They are valve regulated lead acid batteries. So what does that mean? That means that the batteries are sealed. They are not giving off gases. And what was the other part of your question, Olena?
Do we have to ship the batteries after the inverter, or do you guys ship it as one unit?
So we can do it both ways. So if you know that the inverter arriving on the scene is going to be installed within 6 months, then we can absolutely ship the inverter right with the batteries. It all arrives on one pallet and there's no other shipping needed. If you know that the site is a long-term project, the electricians want the inverters there so they can wire them in ahead of time, but they really won't be started up for greater than 6 months, then we can also do the UP option, which allows us to ship the batteries separate from the inverter. And really, when it comes to batteries, you really don't want batteries sitting around for a long time. That's every battery manufacturer or inverter manufacturer. You don't want the batteries sitting around for a long time because the batteries do need to be top charged within 6 months.
Sounds good. Okay. I think that's all the questions that we have for now. Do you have a few more slides?
Yeah, I mean, I can definitely go back into the slides for you. And basically, where we were was, I believe we were getting to the inverter sizing. So real quick, our single phase inverters go from 1,000 watts to 12,500 watts. Our 3-phase inverters go from 3,000 watts to 18,750 watts. So that's basically all I have for inverters, Elena. Do we have time for transfer devices, or do we want to do that another time?
I think we should cover them briefly, just because this is the Inverter 101. And if we have to get more in depth, we'll do it on the next train.
Okay, so basically a transfer device, I will summarize as fast as I possibly can. Transfer devices like this one are required by NEC code. And the reason that they're required, and UL code, the reason that they're required is because, think of it this way. If you go into a room and you flip a light switch or a control, and it's controlling every light in the room, that also means that that control is controlling the emergency lights. Now, if you went into that room and you had the lights on, and then you left the room and you turned the lights off, if there was a power outage and you didn't have a transfer device, that would mean the emergency lights would not come on. So the entire job of a transfer device is to bypass the local control to allow the emergency lights to come on. Back in 2017, UL basically defined these devices as either UL 924 or UL 1008 transfer devices. What those two designations are two very different things. And because of that, a lot of people come up with the question of, well, I don't really understand the difference. They're all transfer devices. Don't they do the same thing? The answer is yes and no. And basically why I say yes and no is because there are some commonalities between the two. The ultimate reason for them existing is the same. They are to bypass controls to allow emergency lights to come on when there's a power outage. So from that premise, they are the same. But from a premise of how they do that or how they accomplish that, it's very, very different. In a 924 device, you are never switching between utility and normal power. You are always connecting emergency power to an emergency fixture. Now, that doesn't mean that the fixture can't be on when there's normal power active. What it means is that it's always sourcing its power from the emergency power provider. So in this case, the inverter. The inverter would always be powering that emergency fixture, even when there's normal power present. So the 924 device brings utility power into it for sensing to see if utility power is actually there or not. But it's only opening a relay to connect emergency power to the fixture. When we're talking about 1008 devices, that actually is physically switching between two power sources. So it's switching between utility power and emergency power. In both instances, this emergency device, or excuse me, the emergency fixture will be illuminated when it's normal conditions, when utility power is present. But again, they're doing it in two separate, different kind of ways. When do you use one over the other? The 1008 device can be used in all situations. So low voltage dimming, switching, high voltage dimming. Definitely can use the 1008 device on much more than just a simple switch leg. You could literally use a 1008 device to supply power to an emergency panel, say. With the 924 device, though, it has its limitations. So you can never, ever, ever, and this is not just for us, this is across the board. This is for all manufacturers. You can never use a 924 device to accommodate high or line voltage dimming. So 924 devices are good for low voltage dimming. They are good for switching applications. They are good strictly at the switch leg level, but you can never put more than a switch leg on one of these devices. So those are the main differences. And you may be asking yourself, well, why wouldn't I just use a 1008 device because that does everything? And the answer is because a 924 device is about 1/4 the cost of the 1008 device. So it really comes down to 1008 devices that can do everything, but it's the more expensive option. You should always be looking to the 924 device because it's more cost effective, as long as you're not doing line voltage dimming.
So if you need phase dimming, then we use the 1008 devices.
You got it. Yep.
Easy peasy.
So real quick, our device is the ELCD 924. I will preface that 75% of the devices on the market are made by one company and one company only. That company is LVS. LVS makes about 75% of the devices on the market. They sell under their own name. They also sell their design to other manufacturers. And then those manufacturers simply put their name on the device and rebadge that. We also used to do that, but we no longer do that. Our device is an OEM device. It is designed, built by us. It is sold by us solely. And the reason we did that is for two things. One, we wanted to be physically superior to the competition, which we are. The second thing is we wanted to provide a solution that was cheaper than the competition, and we are. So cost, we beat the competition in cost, and quality, we beat the competition in quality. The main reason why we are better is basically this right here. So zero cross switching for high compatibility. If you go into a Home Depot or Lowe's and you walk back to the electrical section, you will see dimmers there. And those dimmers, some of them will have a stamp that says compatible with LED lights. The reason that those dimmers are compatible with LED lights is because they are employing a zero cross switching design. We are doing that same type of thing in our transfer device. We are using zero cross switching. The reason is it allows for compatibility with all of today's LED fixtures. So that really is the main factor why I say we are superior in design. And that's because we are employing zero cross switching to allow for that high compatibility. Real quick, this is kind of how a transfer device works. It's very simplified here, but you're going to connect utility power and your emergency power to this transfer device. You will have a wall switcher control that is also connected to the transfer device. And then you have your normal / emergency lights. If you switch that wall switch on, the emergency lights will go on and off when you switch that light switch on. But if you have a loss of utility power, note that the emergency light is still on, even if the wall switch is in the off state. And that's because the transfer device is bypassing this wall switch, allowing the emergency fixture to directly be coupled with the emergency power source. I also mentioned about 1008 devices really, really quick, because I know we're running out of time. Again, not an OEM device. This is our own device. It is a 1008 device. It is compatible with 120, 277 voltage. It will do line level dimming. It will do low voltage dimming, 0 to 10, dolly. It has a fire alarm interface. You can use this in your controls design and interface your controls directly with our transfer device. It is plenum rated and basically works the same way, except now you have your normal emergency lights and the normal lights. Wall switch controlling both of those. Power goes out. Normal lights go out because power goes out. But note that the emergency light stays lit even if the wall switch is in the off state, again, because the 1008 device allows direct coupling of the emergency light to the power source, the emergency power source. That's all I have for you today, Olena. I can certainly stick around and answer any questions that you may have, the attendees may have.
Yeah, so we'll stick around, guys. Thank you so much. I guess the only other thing that I would like to, on that note, for the UL924 devices, it works with any pretty much control system out there. So I know that there is a shortage of those devices nowadays. So if you need UL924 devices, Evenlite's got them. They are in stock, and we've been fixing a lot of projects with them. So thank you so much for that. And if you have any questions, we'll hang out for a few minutes and answer those. And if not, thank you so much for your time. We'll have a more deep dive on the Evenlite offering and more technical training in about 2 weeks. We'll reach out and let you know, and hopefully you can join us then too.
Thank you, Olena.
I see people dropping off, so I guess let's just hang out for a few and see if there are any additional questions. And I'm going to stop recording too.